This aircraft may one day carry the call sign Air Force One. Before we take off into today's video, a quick reminder. If you enjoy in-depth explorations of cutting-edge aircraft, next-gen defense systems, and game-changing military innovations, support the channel by liking this video, sharing it, and subscribing with notifications turned on. Your support keeps us uncovering the tech and tactics shaping the future of warfare and aviation. Thanks. A Boeing 747-8 Intercontinental, valued at nearly $400 million, formally gifted to the United States by the royal family of Qatar. It represents the most advanced and capable iteration of one of the most recognizable aircraft ever designed. Larger, faster, and more efficient than any previous variant, it embodies the absolute upper limits of commercial wide-body aviation. In its current configuration, it is less an airplane and more a flying palace, a platform built to deliver heads of state in unmatched comfort across intercontinental distances. But prestige and performance alone do not make an aircraft suitable to serve as Air Force One. In its present state, this 747-8 offers little more protection than any other civilian wide-body aircraft. Beyond basic aviation safety systems, it lacks the layered defensive capabilities required to safeguard the President of the United States, arguably the highest value airborne target on the planet. Against threats more severe than turbulence or weather, it is functionally defenseless. Transforming this aircraft into Air Force One is not a matter of simply installing additional hardware. The challenge is far more complex and far more consequential. Air Force One is not merely a transport aircraft. It is a hardened, survivable, airborne command and control platform. It must function as a mobile White House, a secure military command post, and a continuity of government asset capable of operating through the most extreme conditions imaginable. The fundamental problem lies in integration. How do you embed encrypted global communications, electronic warfare systems, missile counters, EMP hardening, and redundant power and cooling networks into an airframe that was meticulously designed to maximize openness, elegance, and luxury? How do you route miles of cabling, shield sensitive electronics, and install classified systems without compromising structural integrity, safety, maintainability, or revealing their presence at all? In short, how do you conceal a fortress-level military system inside an aircraft designed as a luxury masterpiece without destroying the effectiveness of either? That question defines the challenge ahead and determines whether this aircraft becomes the next Air Force One or remains simply the most lavish jet ever gifted to the United States. A giant of the skies. From nose to tail, this aircraft stretches an astonishing 250 feet and 2 inches, placing it among the longest airplanes ever to take to the air. That length makes it nearly 20 feet longer than the current VC-25A Air Force One, and only 14 feet shorter than its own wingspan, a rare and striking proportion even among wide-body jets. If the aircraft were somehow stood upright on its tail, it would tower as high as a 19-story building, an unmistakable reminder that this is not merely an airplane, but a flying skyscraper. The fuselage itself spans 19 feet at its widest point, allowing for an expansive 20-foot-wide main deck cabin, a dimension that fundamentally changes what is possible inside the aircraft. This extraordinary width enables wide corridors, full-size rooms, and open lounge spaces that feel less like an aircraft interior and more like a luxury residence or executive office complex suspended at altitude. Supporting this massive structure is a wingspan of 224 feet 5 inches, wider than a football field is long. At each tip, the wings curve upward into 11-foot-tall winglets, carefully engineered aerodynamic surfaces designed to disrupt the powerful vortices that form at the wing edges during flight. These vortices create drag and waste energy. Breaking them up reduces aerodynamic resistance and improves fuel efficiency by approximately 2%, a modest-sounding figure that translates into thousands of gallons of fuel saved on long-range missions. The wings themselves cover a staggering 5,963 square feet of surface area, roughly equivalent to 5 full-size tennis courts laid side by side. This vast lifting surface is what allows the aircraft to carry enormous fuel loads, heavy systems, and lavish interiors while still maintaining intercontinental range and high cruise speeds. Even on the ground, the aircraft's scale is unmistakable. When parked at the gate, the cockpit windows sit level with the 5th floor of a typical office building, forcing ground crews to look up as if addressing a control tower. It is a presence that dominates any airport apron it occupies, an unmistakable symbol. Power and performance. Hanging beneath the wings are 4 General Electric GEnx 2B67 turbofan engines, representing a generational leap over the power plants used on today's Air Force One. Each engine produces 66,500 pounds of thrust, roughly 14,000 pounds more than the CF6 engines on the VC-25A, while consuming 15% less fuel per pound of thrust. This efficiency comes from a high 8-to-1 bypass ratio. For every pound of air passing through the combustion core, 8 pounds flow around it through the fan section. That moving wall of cold air generates most of the thrust, resulting in lower noise, smoother flight, and greater efficiency. The fan itself measures nearly 9 feet in diameter, using 18 carbon fiber composite blades that weigh half as much as titanium, while handling the same stresses. Inside, ceramic matrix composites line the combustion chamber, allowing temperatures of 2,400 degrees Fahrenheit, materials that simply did not exist when the current Air Force One was designed. Range without compromise. The Boeing 747-8 Intercontinental is engineered to operate at extraordinary scale, with a maximum takeoff weight of 987,000 pounds. Its empty operating weight sits at roughly 485,000 pounds, leaving more than 500,000 pounds available to accommodate fuel, passengers, cargo, and mission-critical systems. This structural payload capacity provides the flexibility necessary for VIP configurations, defensive systems, and advanced communications equipment without compromising aircraft performance. Fuel storage is distributed across the wings and center fuselage, totaling 63,000 gallons. At standard cruise consumption, this fuel volume supports over 22 hours of continuous flight, providing true intercontinental capability. With a maximum unrefueled range of approximately 8,000 nautical miles, the aircraft can operate non-stop on strategic routes such as Washington to Singapore, Washington to Dubai, or nearly any capital city on the globe. For perspective, the current VC-25A reaches only 6,800 nautical miles and requires 16% more fuel per nautical mile, demonstrating the efficiency and extended reach of the 747-8 platform. Cruise performance is equally impressive. The aircraft maintains Mach 0.855, or roughly 570 miles per hour, at optimal cruise altitudes between 35,000 and 40,000 feet. Structural and aerodynamic limits allow the aircraft to briefly accelerate to Mach 0.9, though long-duration operations are conducted at standard cruise to balance efficiency, engine longevity, and passenger comfort. The service ceiling tops out at 43,100 feet, enabling operations above commercial traffic and most adverse weather while maintaining sufficient atmospheric density for engine performance. In combination, these characteristics, high MTW, massive fuel capacity, extended range, and high-speed cruise, provide a platform capable of global reach without compromise, essential for a presidential aircraft tasked with rapid intercontinental deployment under any operational scenario.
The airframe. Delivered in 2012, this Boeing 747-8 is just 13 years old, a number that may initially raise eyebrows until it is placed alongside the aircraft it would potentially replace. The current VC-25A Air Force One entered active service in 1990 and has carried American presidents for more than 3.5 decades. By comparison, the Qatar-gifted 747-8 is not aging, it is barely out of its infancy by wide-body aircraft standards. Modern long-haul aircraft are not judged by calendar age alone, but by flight cycles and flight hours, the true measures of structural fatigue. The 747-8 was engineered for approximately 35,000 pressurization cycles and up to 135,000 flight hours, thresholds designed to support decades of heavy commercial use. A high-frequency airline jet may accumulate multiple cycles every day, rapidly consuming that structural lifespan. A VIP aircraft follows an entirely different operating profile. Flights are far less frequent, mission planning is conservative, and operational stress is minimal. Landings are smoother, payloads are carefully managed, and the aircraft spends the majority of its life sheltered inside climate-controlled hangars, protected from corrosive environments, temperature extremes, and weather-related wear. Maintenance schedules are not merely compliant, they are obsessive, often exceeding manufacturer and regulatory requirements. As a result, a 13-year-old VIP-configured 747-8 with low cycles and meticulous upkeep is, from an engineering perspective, effectively in its prime. Structural fatigue is negligible, key components remain well within design margins, and long-term service life extends decades into the future. However, the airframe itself is only the foundation. Aluminum, composites, and turbine hours are not what make an aircraft worthy of the Air Force One designation. The true value and the true challenge lies within the fuselage. What transforms a wide-body jet into a flying White House is not its age or performance, but what is installed inside it, and whether that interior can be adapted to house the most secure, resilient, and capable airborne command platform ever built. Inside the Flying Palace. Boarding through the main entrance, passengers step into a private corridor leading directly to the presidential suite. No aisles, no crowds, no unwanted encounters. This aircraft was designed so VIPs remain completely isolated from staff and crew. The primary bedroom occupies the forward section of the main deck, replacing what would normally be first-class seating. At its center is a full king-size bed, permanently mounted and stabilized for flight, something no U.S. president has ever had aboard Air Force One. Surrounding it are floor-to-ceiling custom wood panels, hand-matched grain patterns, indirect LED lighting, and individualized climate zones. The adjoining bathroom rivals a luxury mansion, complete with marble countertops, gold-plated fixtures, and a multi-head shower with residential water pressure. There's even a second master bedroom, because when you're Qatari royalty, one simply isn't enough. Offices, lounges, and space to work. Adjacent to the suite is a private office with wood-paneled walls, a full executive desk, and a leather swivel chair secured for turbulence. It's designed for real decision-making at 40,000 feet, not a folding tray table.
Beyond that lies the main lounge, a space that feels more like a five-star hotel lobby than the interior of a jetliner. Leather sofas, reclining chairs, integrated entertainment systems, electronically dimmable windows, and nearly 8 feet of ceiling height make it easy to forget you're airborne. Aft lounges provide quieter, more private areas, while the rear of the main deck houses business-class seating for staff, Secret Service, and military aides, far more comfortable than the cramped arrangements aboard the current aircraft. The upper deck and the security problem. Above the main deck is a 60-foot-long upper level offering about 1,000 square feet of space. On this aircraft, it features lounges, seating areas, and a full galley connected by a wide, polished staircase. For royalty, it's elegant. For the Secret Service, it's a security choke point. On the current Air Force One, the upper deck isn't a lounge, it's a flying data center packed with encrypted communications, server racks, cooling systems, and direct links to nuclear command authority. This jet has none of that. From palace to fortress. At present, the aircraft's defensive capability is minimal, essentially limited to ground intrusion alarms. There are no missile countermeasures, no electronic warfare systems, and no EMP hardening. To serve as Air Force One, it must be equipped with infrared missile defense systems like the AN/ALQ-204 Matador, chaff and flare dispensers, radar jamming equipment, and full electromagnetic pulse protection. EMP hardening alone requires transforming the aircraft into a continuous Faraday cage with flawless conductive shielding hidden behind luxury finishes never designed to conceal military hardware. Every cable, antenna, cooling duct, and server rack must be installed without visibly altering the interior. That's the problem.
The race against time. The aircraft currently sits in San Antonio, where L3Harris Technologies has begun planning the conversion. Experts estimate timelines ranging from 18 months to several years, with retrofit costs between $100 million and over $1 billion. Meanwhile, the purpose-built VC-25B aircraft, designed from day one to be Air Force One, remain under construction, years behind schedule and billions over budget, with delivery now projected for 2027. If the Qatar jet can be converted quickly, it may serve as a temporary bridge. If not, the current Air Force One will continue flying, and this aircraft could become the most expensive museum exhibit ever donated. Because if it is not placed into government service by January 2029, ownership transfers to Donald Trump's presidential library. Engineers are only just beginning, and the clock is already ticking. If you enjoyed this video, subscribe and stay connected. Thanks for watching. See you in the next video.